Okay. So again, there's the homework. There's the calendar. I'll get this posted on the website so you can have a copy of it, or maybe I'll make a copy and bring it tomorrow. But today we're going to cover section 7.1, and it's an idea that you're probably already familiar with. So I'm going to go through very quickly, and then hopefully give you some time to work on this in class. So this section is on solving systems of equations by the substitution method. Okay, but we're going to go through the idea, at least for 2 dimensions, at least for x and y. We're going to go through this in a fairly simple way. We're going to do this by graphing really quickly, and here's the point. If I do this one in red and I do this one in blue, first of all, I need to put those in a graph-friendly form. So I'm going to make this one y equals negative x plus 3. And I do this one as, this is going to be y equals, if I just move the 1 to the other side, this is going to be x plus 1. Minus 1, thank you. See how silly that is? All right, so let's go ahead and graph this one. This one crosses the y-axis at negative 1 and has a slope of 1. So it looks like this. Okay, now I mentioned this before, but please don't forget this. This is a picture of all the points that work in the equation. So if a point is on the line, it works in the equation. And if it works in the equation, then we put it on the graph of the line. All of these, for the time being right now, happen to be lines. Okay? So this blue graph is a picture of all the points that work in the blue equation. And if I were to graph this one crosses at 3 with a slope of negative 1. Okay? If I connect those points, put an arrow on the end. Okay, that red line is a picture of all the points that work in the red equation. Well, if I'm solving a system, what I'm doing here is I'm solving for a point or an xy pair that works in both equations at the same time. In fact, sometimes we'll call this solving a system simultaneously because we want it to work in both of them simultaneously at the same time. And if you look, the point that works in both of them would be the point where the lines cross. So this looks like that would be 2, 1. Now, how could I check and make sure that that actually works? Plug it in. 2, 1. 2 plus 1 is 3. This is 2. This is 1 plus 1, so 2 equals 1 plus 1, so it would work in both equations. So you can always check to see that you got the right answer by plugging it back into the system. Okay? And usually we're going to want to write these as ordered pairs. So on this particular one right here, the solution would be, 2, 1, that's the x, that's the y. It indicates that's where that's the point where these 2 curves or these 2 lines in this particular case cross. All right? So the substitution method is the most basic method of solving outside of graphing, but graphing can be a real pain in the butt because you've got to draw a nice, accurate graph, but if they don't cross at nice points, then you're in big trouble because it's really hard to estimate what the exact answer is by looking at a graph. So we're going to learn some algebraic techniques, or probably review some algebraic techniques. The first one's called substitution, and tomorrow we'll do elimination. Okay, and then we'll just build from there. And we will deal with some more complicated graphs than just linear equations, but here's how this works. So substitution goes like this. We're going to isolate one of the variables in one of the equations. We're usually going to choose the easiest equation and the easiest variable to isolate. The next thing we're going to do is we're going to substitute the equation that we found in step number 1 into the other equation, whichever equation we didn't use, or one of the equations that we didn't use, we're going to plug that in. And it's always a good idea that when you're using substitution, put parentheses around the things that you're plugging in. Solve the resulting equation in step number 2, because at that point, hopefully it has just one variable. If not, you've got a little bit more work to do. Okay? And then we're going to do what's called back substitute. Back substitute the answer in step number 3 into the equation found in step number 1 to find the other part of the solution. And then again, usually we're going to write our answer as an ordered pair. And a lot of times it's a good idea to check and see if your answer actually works. I mean, maybe you made a silly mistake or something like that and it works in one but not in the other. Okay? So a couple of quick examples. This one is set up for substitution. If you already know what elimination is, okay, this one's set up for substitution. Go ahead and do it by substitution. So wherever there's an x, we're going to put a y plus 1, and we're going to do that in the first equation. So this is going to be y plus 1 plus y equals 3. This is going to be 2y plus 1 equals 3. So this is going to be 2y equals 2. So that means y equals 1. I've got one of the answers. Then the best place to back substitute this, I could plug it into the first one. But if I plug it into the second one right here, this is the advantage I've got. This says x equals 1 plus 1. So x equals 2, and there are the two answers. Okay, how should we normally write this? Ordered pair, 2, 1. Okay, any questions? Okay, this one's not set up for substitution, but the instructions say solve this by substitution. So you choose one of the equations and one of the variables to get by themselves. Okay, now, which equation and which variable would be the easiest to solve or isolate one of the variables so that we can use substitution? First equation an x or y, second equation or x and y. Second one's not bad. Here's why I like the first one. Okay, both of these would be good choices. If I did the first one, I'm going to isolate x. I'm going to get x by itself. If I did the second one, I'm going to get y by itself. If I got y by itself, I'd have to move the 4x to the other side by subtracting. I'd have a negative to deal with. And people tend to make more mistakes with negatives. So if I take this first one and I move the negative 2y to the other side, this is what I get. You'll notice that everything there is positive. I'm less likely to make mistakes with that. So here's what I've got. 4 times x. In place of x, I'm going to put 2y plus 16 plus y equals 1. Distribute through 8y plus 64 plus y equals 1. So this is going to be 9y plus 64 equals 1. That's going to be 9y equals negative 63. So I get y equals negative 7. Then I'm going to take that answer and what am I going to do with it? I'm going to back substitute it into this one right here. I could plug it into this one here, one of the original ones. This one right here, another one of the original ones. But this one right here, if I plug it in right there, I get x equals, this would be negative 14 plus 16. So I get x equals 2. The nice thing about that, it's already solved for that other variable that we're still missing. So it's a very easy algebra problem. It's almost just arithmetic at this point. So the answer is 2, negative 7. Any questions? Okay, raise your hand if you've seen that before. Everybody, right? So just a quick reminder. Okay, let's take a look at example 3. This one's a little different. Story problem, but we're going to solve this using a system of equations. Sally invested $10,000 in 2 funds that paid simple interest at rates of 8% and 12%. In 1 year, she earned $1,056 in interest. How much did Sally invest in each fund? Okay, now listen carefully because this is going to come up again and again and again. Whenever you've got a story problem and you've got to solve it using a system of equations, usually you're going to write a couple of equations about different things. Okay? So I'm going to declare a couple of variables here. I'm going to say x is amount in the 8% fund. And I'm going to say y is the amount in the 12% fund. Now, if I took this many dollars and put it in the 8% fund, and this many dollars and put it in the 12% fund, and all together I invested $10,000, x plus y should equal 10,000. I invested $10,000 all together. All together means we'd add those together. Okay? This is an equation about amounts. Okay, now we're going to write an equation about interest. Now, does it say how much interest she earned? It does, $1,056. Okay, but you'll remember, if I invest X dollars at 8%, if I did $100 at 8%, I'd earn $8 in a year. $200 times 8% would be $16 in 2 years. So the way I represent how much money I make in a year using simple interest, remember that formula is PRT, principal times rate times time. The time is 1 year. We don't know how much we put in that account, but it was put in at 8%. So we're going to represent this as 0.08 times X. That's going to be the interest that I earn at 8% if I put X dollars in. What's this one going to be? 0.12. 0.12y. So this equation is about the amount of money I put in. This equation is strictly about the interest. That's the interest on the 8% account. That's the interest on the 12% account, and that's the total interest that I got altogether. Okay, once I get this, okay, again, I want to solve this by substitution, but I want to do a couple of things first. Take a good look at this. Okay, is there a way we could make this so that we don't have to work with decimals? Tara, what would we do? Move all the decimals over 2 places. So here's the equation that I'm going to work with. Okay, I'm going to go ahead and solve this for one of them. I'm going to say y equals 10,000 minus x. And the other equation, I'm going to write that as 8x plus 12y. And on this one, add a couple of zeros. Now, if you don't mind working with decimals, you certainly don't have to do that. You could keep the decimals and then plug this into that right there. Okay, that would be totally okay. But if you don't want to work with decimals, that's a good way to get around it. So I've isolated the y. I'm now going to plug, wherever there's a y, I'm going to put 1,000 minus x. And this is really important. 8x has to go in parentheses. 10,000 minus x. 105,600. This gives me a minus 4x on this side, and when I do the subtraction, when I subtract 120,000, oops, one too many zeros. Let's see, I get, is that 14,000, negative 14,400? Is that what that is? Is that right? And then I just divide both sides by 4, negative 4. So I get x equals 3650? 3600. Okay? Okay, and since that represents the number of dollars that I invested in the 8%, okay, so $3,600 at 8%. Okay, and then I can plug that in here. I'd take 10,000, I'd subtract 3,600, and I end up with y is equal to 6,400, right? So, at 12%, at 8%. Any questions there? Sure? Okay, let's look at the two of these because these are different. What do you notice is different about these? What's that? There's an x squared, okay? What shape does that make then? A parabola, okay? So we've got a parabola here and a line here, and we want to solve this by substitution. So we're going to go ahead and do this one. Again, pick one of the equations to solve for one of the variables, and by far, which one is the easiest to solve for here? The second one, and which variable? Y. So we're going to isolate this y right here. I'm going to do this. I'm going to move the y to the other side and the 1 to this side. So I get y equals 2x plus 1. Good? I'm then going to take this and I'm going to put it in right there. And again, you've got to be careful with this. x squared plus 4x minus, I would put these in parentheses, so minus 2x plus 1 equals 7. And from there, you've got to rack your brain a little bit because it's been quite a while since we did this, probably several months since we solved one like this. This is x squared plus 4x minus 2x minus 1. Make sure you get those right. This is x squared plus 2x. If I move this to the other side, that's going to be minus 8 equals 0. What's the technical name for this? Starts with a Q. This is a quadratic equation. We have to solve a quadratic equation. Now, what is our favorite technique? What is the easiest way to solve a quadratic if it works? What is it? Factoring. If factoring doesn't work, what other technique do we always have available? Quadratic formula. So let's try and factor this. This is a relatively simple one. We're looking for two numbers that multiply to be negative 8 and combine to be positive 2. That would be positive 4 and negative 2, correct? What's the solution that comes from this factor? Negative 4, and the one from this one? Positive 2. Is there anything wrong with getting two answers on this? Nope, nothing wrong with that at all. What it means is this is going to cross in two places. How do I get the other parts of the answers? I plug them back in here. So I'm going to put this in here, and I'm going to put that in there. So I get one answer of negative 4, comma. If I plug in a negative 4, I get negative 8 plus 1, so that's going to be negative 7. And if I plug in a 2, I get 4 plus 1, so that's going to be 5. So here's what this means. The parabola and line. What's significant about the parabola and the line at these two places? Okay. Good? Okay. Let's take a look at this one. Okay. Any questions on that one? Which variable is easiest to solve for here? Top one, which variable? Probably y, because if I do y equals x plus 4, I don't have as many variables to work with. So this is going to be x squared. Okay, now this is plus, so not as big a deal that I put this in parentheses, and it's just a 1 in front there. So this would be x plus 4 equals 3. Factor? We'd have to use the quadratic, okay? And we're going to get this far. So again, you've got to have this memorized. Think of the quadratic formula. Write it down. Write it down. Make sure you've got it. Mr. Perfect will sing the Pop Goes the Weasel song in just a second, right? No. Anybody want to sing it? Hope will sing it. Hope, go ahead. I will not be singing it. Okay. So you can learn that using the Pop Goes the Weasel song, but this is what it is. Now, if I plug those numbers in here, watch what happens. This is going to be a negative 1, no problem there. Okay, and I said if people make mistakes, it's usually right here. So this is going to be 1 squared minus 4 times a times c. So let's take a look at that. This is a 1 and that's a 1. That's a 2. Right here, this is going to be 1 plus or minus something. Minus how much? And what's the problem here? Imaginary. So we say no real solutions. And since all the points on the xy plane are all real numbers, what does that mean about this parabola and this line? The parabola and the line do not cross. Okay? All right, any questions? Okay, go ahead and flip the page over. Okay, don't reach for your calculator just yet. Not just yet. Okay, I'm going to graph this one in red and this one in blue. The line is really easy. If I move these around again, I get y equals 2x plus 1. So it's going to cross at 1 and have a slope of 2. So it's going to look something like this. Again, before you grab your calculator, let's stop and think about this here. This would be y equals x squared plus 4x, and this is going to be a minus 7. Correct me if I'm wrong. This parabola opens up, opens up. Where's the vertex? Does anybody remember that little formula? Negative b over 2a. Negative b, negative 4 over 2 times 1. Negative 4 over 2. What's the x-coordinate of the vertex? Negative 2. Okay? Or you could complete the square if you wanted to. Okay? How do I figure out what the y-coordinate of the vertex is? F of negative b over 2a. In other words, we plug it in, right? So if I plug in a negative 2, I get 4 minus 8 minus 7. 4 minus 15, so that would be negative 11, right? Whoops. Yeah, that's right. Yeah, negative 11. Okay. So negative 2, negative 11. There's 2, 4, 6, 8, 10. So about right here. Has this been stretched or shrunk? No. So once I know where the vertex is, can't I use that pattern that we learned? Over 1, up 1 squared on both sides. Over 2, up how much? Up 4. So 1, 2, 3, 4. So we'd be right here. Over 2, up 1, 2, 3, 4. Wow, right there. Okay. Over 3 up 9, over 4 up 16. If I was at negative 11, that's going to put me at 5 right there. Aren't those the points we found before? This would only work because these are relatively easy to graph and they cross at nice points. Both of these intersection points right here and right here, they're both nice points. Okay. Now this is the same one we did on the other side. Again, I'm going to do this one in red and I'll do this one in blue. Okay. What are we going to see here? By the way, these are a lot easier to graph, aren't they? Okay. What are we going to see here if I graph these? What shape is the blue one going to be? Parabola. What shape's the red one going to be? A line. And what do we know is going to happen here? What's that? Are they? What did we get on this one? We got no solution, didn't we? So the parabola and the line are not, they're not going to touch each other at all. Okay? You might want to visualize how would that work if we had, well, let's see, this is a parabola that opens down. What does the plus 3 do? Move it up 3. 1, 2, 3. Stretched or shrunk? Nope. Looks something like that. Where does the line have to go? Where does it need to be in comparison with the parabola? It's got to be above it somewhere. Okay, so let's go ahead and figure out what that looks like. This would be y equals, this is going to be x plus 4. So this crosses right here. and has a slope of 1, it's going to look something like this. They never cross. Okay, they never touch each other. Okay, now, would it be pretty easy to solve each one of these for y, like we did here? Throw them in the calculator, put them in y1 and y2, and have the calculator graph those and see where they cross? Okay. Have we found intersection points before? We have. You know how to do that on the calculator. You know how to hit the second trace button, the calculate. Let's do that just for the heck of it. So this would be 2x plus 1, and the other one is x squared plus 4x minus 7. And if I hit, let's do the standard window. There's that line. Here's the parabola. And we're going to hit second calculate, and we want an intersection point. Let's say I want to find this one right here. It says first curve, do you want the line? We say yes. Second curve, we want the parabola. We say yes. And then it says take a guess. Let's just get kind of close to that point right there. Hit enter. It'll work for a while, and it'll tell us that it's 2, 5. Okay? We've done that before, right? Okay. Any questions? Okay. Let's take a look at the last two. This is problem number 54. It's from your assignment, or it's almost identical to one on your assignment. It says, solve the system graphically or algebraically and explain your choice of method. Okay? Does anybody remember what shape this is? It's a circle. Where's the center? At the origin, and what's the radius? Radius is 5. So it looks something like this. Mine looks a little bit like a snowball. This would be y equals negative 2x plus 10. So it would cross up here and down 1, back 2, down, so like this. Are they going to cross? Definitely going to cross. Figuring out exactly where they cross might be a bit of a pain. So should we do it graphically? Let me ask you this. Could we put it in our calculator and have it do it? Okay, let me show you how to do it algebraically. I'll just set it up for you. Wherever there's a y, we're going to put this. So this is going to be x squared plus negative 2x plus 10, quantity squared equals 25. X squared? Yeah. Oh, did I? Oh, you're right. Yep. Yep. We'll go like this. Yep. Thank you. Okay. I should have gone through and solved it like this. Okay. Would you write down what you get when you square this out? When you square this binomial? What's the middle term here? And there is a middle term, right? When you multiply a binomial. First one squared, last one squared, multiply the two of these together and double it. This is going to be minus 40x. Okay? Minus 40x. And then you can solve this quadratic maybe by factoring if you're lucky. If not factoring, then quadratic formula. Okay? That'll give you the x's, and then you can plug them back in here and find the y's. Okay? I suspect that these answers are going to be pretty ugly. Okay? So, how can you have your calculator graph a circle? No? Okay, here's what we do. I'm going to take this one and I'm going to solve it for y. If I do that, I get 25 minus x squared, and then I'd take a square root. So I'd get y equals the square root of 25 minus x squared. But if I put a square root in a problem, what else do I have to do? Plus or minus. Okay, so this would be the top of the circle, and if I put a minus, that's going to be the bottom of the circle. So maybe do this in y1, that in y2, and in y3, let's grab the line negative 2x plus 10. And then you'd be able to have the calculator graph this picture and find the intersection point. I suspect that this intersects with the top of the circle, and this would intersect with the bottom of the circle. So all you'd need to do is make sure that you're grabbing the right lines when you do an intersection, or the right curves when you do an intersection. Any questions? Sure? Okay. Does everybody feel confident you can finish that? Okay. Let's look at the last problem then. And so I realize that you've done substitution before, but probably maybe not with circles and parabolas and stuff like that. So that may be a little bit of a challenge. Get used to that. Okay. And then we're also going to see applications of these systems of equations quite often. So here's one that you're going to want to be aware of. This is called break-even analysis, and this happens all the time in business and when people are trying to make a financial decision. Okay, they make an investment or they spend some money, they want to know what their break-even point is. Okay, so it says a small business invests $10,000 in equipment to produce a product. So they buy new equipment or whatever it happens to be. Each unit costs $0.65, 65 cents to produce, okay, and is sold for $1.20. How many items must be sold before the business breaks even? So they spend a bunch of money on equipment. They buy the tools that they need to make this product or whatever it happens to be. But then each one of them, they say it's made out of cardboard or paper or metal or something like that. They've got to buy the stuff to actually make each one of them. Okay? So all the tools, and then each item has some material that it takes to produce that. Okay? And they sell each one of them for $1.20. Well, they're making 55 cents on each one, but they've got to recoup this initial cost, so that's their break even. So we're going to write a cost function. X is the number of items. So the cost is found this way. $10,000 to begin with. And how do we show that it costs 65 cents per item? Would we do minus? It's going to add to the cost, so this is going to be plus 0.65 times x. $10,000 up front and then 65 cents a piece. Let's put the price, or let's put we'll do R, okay? So this is cost, and we're going to call this is called revenue. This is how much money we generate when we sell something. How much money do they generate when they sell something? $1.20, right? $1.20. So how do we write down this revenue function? How much money they bring in? $1.20 times x. If 0.65x is how much each one costs, and then 1.2x would be how much revenue is brought in. Okay, it's the price of each item. Okay. And what do we want to know about these things? How many must be sold in order for them to recoup their investment? Okay, before the business breaks even. So if you think about this, and I'm gonna rewrite these. I'm gonna write y equals 0.65x plus 10,000. And on this one, I'm gonna write y equals 1.2x. What shape are both of these? Both of them are lines, right? What's the difference between these two lines? Okay, one starts at 10,000 and goes up, but is 0.65 a very steep slope? It's not. So it does something like this. Where does this one start? Starts at 0, but it's got a pretty steep slope. It's twice as steep, right? Bless you. So, if you owned the business, describe what's going on right here. If you owned the business, describe what's going on right here. You're in debt, aren't you? Okay? You spent all this money, and you're spending money every time you make an item. Okay? You've spent more than $10,000, but this is how much money you've brought in when you sell them, right? Okay. What happens over here? You're profitable, right? Because your revenue, the money you're bringing in, is more than the money that you've spent to make the items. Okay? So you're at a loss right here. You're at a profit right here. So this is loss in this area right here. Okay? And this is profit over here. Well, what happens right there? You're even. Okay, so let's make sure we're clear on how this works. You're working at a loss here, so everywhere from here to here, you're at a loss. Everywhere past here, we're making a profit, and right here, we break even. So, how many do we need to sell in order to break even? How do we solve this? And is it a point? Is it an x coordinate? Is it a y coordinate? It's really an x coordinate. If you think about the way they said, how many items must be sold? What does x need to be for those two lines to be the same? Solve that system of equations, set the two of these things equal to each other, and you'll have your answer. Okay? 1.2x equals 0.65x plus 10,000. Do you remember me saying something about they're selling them for 55 cents more than they cost to make? What happens when I subtract 0.65 here? 0.55x. They make 55 cents on each one of them. And if you take that $10,000 and divide by 0.55, that'll tell you how much money or how many they have to sell in order to recoup that cost so they can break even. Okay. And what'd you get? Exactly? 0.81. 818181. Okay? Okay, if this is the number of items and you were in charge of the business and you had to decide between selling 18,181 and 18,182, how many would you want to sell if you actually wanted to break even? Yeah. 18,182, because then you'd make just a little bit more. You probably have a couple pennies in the register. Okay, before that, you don't quite have enough. If you only sold 18,181, okay, you wouldn't quite break even. Okay, you'd have to round to the nearest, you'd round up. In other words. Okay, any questions? Okay. Again, that's the homework. Okay, so there's only, what do we got here? 11 problems or so? Okay. Have these done tomorrow. We'll correct this at the beginning of class tomorrow, okay? Should be relatively easy. Okay. All right.